Example throwing upward there. So if you would draw the cliff, and we're taking notes on day 3, Hunter, where it says free fall, but we're combining notes on day 4, and it's called throwing upward. So find your day 3 notes, Hunter, and where it says free fall, just add that we're doing day 4 and throwing upward on that same page. We already had started one with the gun problem, so we're doing another one. Draw a cliff and someone throwing something upward off the cliff, and it's going to come back down below, maybe below him. Let's see, and this problem ends at 0.6 seconds. So the question is, write it, find the position after 0.6 seconds. I'll give 2 sig figs to that. So there's what we're looking for. So once again, we always do our little checklist. Do we know anything else about this problem? We need to know one other thing at least. Yes, we do. When it came off the guy's hand or the girl's hand, it was at 2.3 meters per second. That's the initial velocity. So, given the initial velocity, going straight upward, coming back down, find the position in 0.6 seconds. All right, you pull out your variables, x, v, o, b, t, and a, and you ask yourself what is known and what isn't. Go through the checklist, mark which ones we know or must be in the problem, and tell me what equation I should pull out of our hat. Hunter, you can do that too. Will just be a minute. So after your analysis, is it going to be the boater? Is it going to be the squaller? Or is it going to be the attacher? Which one is it? Zach, did you answer?
The third one.
The third one, the motor. All right, we'll check that answer as we put in the values. So x is what we're looking for, find position. So that is our x, so we do have to have that in the equation. E sub o is given, time is given, hat 1/2, acceleration, because this is a free fall problem. We know it's the acceleration due to gravity. Let's do this one in feet just for fun. It doesn't say whether to do it in feet or not. So let's say find the position in feet, just because we don't use that number very often. So it didn't say which way, so in a quiz or a test, you really have a choice. So it is negative 32 feet per second squared, and most of the problems you don't have a choice, but notice this one only gave you time, so it didn't give you a clue which way to work. So we're taking feet in this one, and we're taking 0.6 and squaring it. No algebra in this one, it's just plug and chug arithmetic, just putting these numbers into your calculator. Pull out your calculator and pull it out and plug those numbers in. Give me 2 sig figs. We also get the same number using the same precision. Have a number, Emily Martin?
We're at negative 1.4.
Anyone confirm? Nope. What did you get then? Anyone else get a different number? What'd you get, Zach?
7.14.
Pardon?
7.14.
7.
Well, negative.
Negative 7. Did you say 4.4? Negative 7.4. Is that what you said? All right. We need to have it confirmed one way or the other. It looks like I did it in meters, so I don't know.
Oh, wait, 1.
Oh, wait.
7.14?
Yeah.
So that's 7.1.
Negative 8.2.
Negative 8.3. Okay, why did I do this at home? Yes.
I got negative 4.4.
Which one?
The 4.4.
This one?
I'm by myself here.
I got negative 4.3, negative 4.4.
Okay, go on
What
with
did I
it.
do wrong?
Sorry, dudes. I don't know. Did you square the 60?
Oh, no, I didn't square.
2.3.
Okay, now.
Not,
Oh, wait.
not
Now
60,
I'll be the
it's
deciding
It's
factor.
0.6. 2.3, 0.6 plus 1/2 minus 32.6 squared. It's negative.
I still get the same.
So this
Oh,
is-
I know.
What do we get?
What is it?
Are you subtracting?
Yeah, I got 3. I got
What you
4.4.
Yeah.
That
Because
would
you're
do
getting
it.
negative
Alright,
4.38,
okay.
which is negative 4.4.
Yeah. Okay. So we have a position of negative 4.4 feet. So if you would, interpret that in light of this problem. Why are we coming up with a position that's negative? What do you think, Emily Keene? Why is it negative?
Because it's below where you originally started.
Right, exactly. So if a number comes out negative, as far as position, it just means it's below where it was. Actually, we should be counting from this where it released from his hand or her hand, so it's below where it started. So that's what the negative sign means. All right, that's just sort of to bring us back to where we were before the weekend. So a little bit of lab blab now. And do you recall, was it Friday we did a lab? And we were asked to do the reaction time for ourselves and a partner. Do you remember the 4 steps of a lab report? Calculations of data, make sure you have correct precision with units, a paragraph on what the procedure was, your conclusions. On this lab, I'm looking, the conclusion is rather simple. I used blah 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 formula, or blah 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 formula was used to calculate reaction time, and the reaction time was blank and blank. There's really not much to conclude on this one. And then the principles used, we had all kinds of principles, sig figs, measurement, position. Which formula we used on that one? Was it the this one? I can't remember on the lab.
Yeah.
Is it that one? You could mention that this formula was used, or you could just call it position equations were used. What else could we say? Timing. We used measurement because we were looking on the metric system there, the metric ruler. All right. Well, anyhow, come up with as many of the principles of physics then from class that you used in that lab. There were some of them. And it's actually due tomorrow. So does anyone want to hand it in early? I'll take it. All right. One last thing. All right.
We should make it due Wednesday.
Pardon?
We should make it due Wednesday.
I almost said that but, last week. I said, that's not going to work. I'll drive down the city and collect your labs. All right, questions on what I expect? Have your lab ready tomorrow. All right, our next topic. Day 5 was really just the experiment, so that's why the last thing we talked about was 4, and what's coming up is day 6. If that bothers you, you can put on the top, day 5 was experiment. So we're on day 6, and we take notes here.
What happened to day 5?
Alex. He literally just.
I was literally not paying attention. I was reading the paper is what I was doing.
Day 5 is the experiment that we did,
Wow.
so if that bothers you, you can put that up top. Day 5 was experiment, day 6 is terminal velocity. Is that a movie or something? Sounds like it.
I'll make a movie. I'll produce a movie. Terminator Velocity.
Starring
Starring me.
Dedicated. Sorry.
How
Dedicated
many
to
minutes
physics.
are we at, Brandon?
We're at 9:45.
Okay, that's good.
You should be paying attention.
Terminal velocity is our topic for today, day 6. So let's get them into the old and into the new. Terminal velocity is, first of all, let's describe what's happening, and then I'll define, when an object is falling, and then I'll describe or define terminal velocity. So here's where we're heading. Terminal velocity. Brandon, could you shine a light on this paper for Hunter? And I'll lay one out to give to the
Camera.
substitute folder, or the absentee folder.
Here you go, Hunter.
Velocity.
Terminal velocity,
looking at.
physics chapter 2, day 6, featuring Miss Powell.
You want to tell her what happened on day 5? No,
On
she
day-
heard that.
oh.
That's all right. All right, start.
I'm taking
Start
control
on your
now.
notes and fill in the blanks. As an object falls. As an object falls.
Be a
It
cameraman one day.
goes blank and blank. See if you can fill
See
in
that,
something
buddy?
that
You see
makes
it?
sense.
Alright, you read that? Alright, yeah, that was good.
As an object falls, it goes blank and blank. See if you can think of something that would go in there that makes sense.
It goes faster and
This is
faster.
not the definition, but we're building up to it. Yes.
What was the experiment? Number.
We don't ever call it experiment. We give it a meaningful title. What would be a meaningful title for that experiment? How about reaction time?
Reaction
Yeah.
time.
Data sheet.
Okay.
This song.
Okay. Experiment 2. That'd be good enough. All right. Okay. Good job. All right. As an object falls, it goes.
Alright, so are everybody do those poster problems?
Yeah, we're gonna finish those. We're gonna work on those a little bit each day.
Faster and faster.
Yeah, yeah.
As an object falls, it goes. Did you put something like faster and faster?
That's what I said. Yes. Yes. Let's go.
I got that record.
Let's go. Going to the Super Bowl.
Because it is accelerating.
Hit that 12 minute.
Okay, that'd be good. Then you just either close that little flap or hit that button. Either
Yeah.
one will